Everyone, welcome to this video. In this video we want to discuss about the Giaver tunneling. This is actually a single electron tunneling. This is a part of the superconductivity. The previous lecture already discussed the other part. In this lecture we want to discuss Giaver tunneling. You know what is the superconductivity? It is the state of the metal at which the resistivity tends to zero after below a certain temperature called the critical temperature, right? So below the critical temperature, the metal behaves a low resistivity tends to zero. There is a sharp change below the critical temperature, and this is the superconductivity. There are various property already discussed in the previous lectures. In this lecture, we want to discuss this Giaver tunneling. What do you mean by Giaver tunneling? Suppose there is a two metal separated by a insulating which is nearly about 10 to 20 angstrom. Okay. Now, if you apply a external source, voltage source, then the current will be flow due to tunneling, because there is a energy barrier. If you want to draw the energy band diagram, this is metal 1, this is metal 2, and there is a energy barrier. The electron cannot go through this, overcome those potential. They can tunnel through this insulator, and after this certain voltage, this can a linear curve will be attained. Now the question arises, why these low current are passing through this metal? This current is passes through the due to thermal agitation. Thermal agitation. Okay, agitation. This is due to thermal agitation. Right. Now, if we want to make a one side of this metal as a superconductor, this is a superconductor, and other side is a metal. Okay, then what happen? This is a insulator. In this is a insulator. Okay, so then what happen in the energy band diagram? If you know if there is a Fermi level arise in the superconductor, you know there is a band gap arises in superconductor. You want to draw the energy band diagram. This is a superconductor, the energy state, and this is also energy state. This is superconductor, this is insulator, and there is a metal. This is another metal. Okay, this is insulator. Clear? This gap is known as delta. You already know from the previous lecture. This is the energy band diagram delta. Then the potential into charge. This is energy band diagram. So this is energy gap by Q. This is the minimum required voltage above which the energy can pass through the electron. That is in the IV curve. The voltage above which this is linear. The voltage, this is VB, breakdown voltage, you can say, above which this is linear, or it can be as a Ohm's law. Obey Ohm's law. Okay, below that this is a tunneling. This is a single electron tunneling. Tunneling. This phenomena is single electron tunneling, and this is first observed by Giaver. That's why this is called Giaver tunneling. Giaver tunneling. Okay. So this tunneling will be discussed in the next class. That is the Josephson, AC Josephson effect and DC Josephson effect. We will be discussed in detail of the Josephson. Again, in this lecture, we learn about just the what is the tunneling effect of the glacier tunneling, or the single electron tunneling effect. Okay. Thank you for listening. We will meet in the next video.